Ever wonder how you could use FIDO for SSH? I'm going to show you how right here, right now.
All I'm offering is the truth.
Give me your systems display.
Last chance to get out of this without a prison sentence.
The Matrix is everything. It is all around us.
All right, there was a little tension breaker that had to be done, all right?
So when you first set up your box and you set up SSH on it, it's probably going to set up a username and password for you to log in. That's the basic way of SSHing into machines. The problem is an adversary, if they get a hold of your password and your username, they can come from any machine to be able to get into it. So the one thing that you want to do is make sure you do not deploy this method. If you do deploy it, and I highly recommend you don't, at least put a different password on every computer, because when your password gets compromised, at least you limit the impact area of your machines. But again, don't deploy this method. I am going to show it here just to kind of show you a little bit of what I'm talking about. Okay, here's the shell window that I'm going to be using to communicate to these boxes that I have. Now the bottom shell window, this is my local Mac machine that I'm on. I'm going to be using this through the entire demo. The top one here, SSH2, is whenever I need to run commands on the remote box. That's the window that I'm going to use to do that. But just to start off, I'm going to begin by SSHing from my local box with a very basic command. The machine is ssh2 lab.loc, and it's going to ask me for a password. And if I had a keylogger or something grabbing my password, I can get into the machine. So there you go, very quick, easy login. Okay, this next section I'm going to cover is using public and private key pairs to authenticate your account to a remote machine. What we're going to cover in our demo is we're going to create that public and private key pair. And what you need to do is you need to take your public key from that pair and copy it out to the remote host that you want to authenticate. In our case, it's SSH2. And we take that public key and put it into an authorized keys file that's in the .ssh directory. Again, I will cover this as we go through the demo, but just know that one of the steps you need to take after you create your key pair here is you need to take your public key and make sure it's copied over to the machine that you need to authorize into. Now here in the demonstration, I'm going to show where your private key is password protected. Now that's not by default. You can put no password in for your private key, but that's not a good way of practicing security of your private key. Because if an adversary gets a hold of that file, they can easily use that to authenticate into the machine. But even if they got a hold of the file that is password protected, if they got a hold of that file, they can brute force that file offline. So you still do have a little bit of risk there. But you know, some of the reasons why you would do this is it's an easy step up authentication mechanism from the default of username and password. You're providing that additional layer of security here. It's good for small deployments, and the reason I say small deployments and not larger deployments here is because you are required to take your public key and push it out to a file on all of the remote machines that you're authenticating into. I will cover a way for an organization to take advantage of a certificate authority a little bit later as well. So there is that administrative overhead of copying this file out to all the machines, something you may or may not want to do. The other thing is you as a user, if you want to move to another machine and authenticate from that machine, you need to securely port over your private key to that other machine. So there is that security risk that you have moving your private key from one machine to another. So you know, that opens up an adversary getting a hold of your private key and being able to brute force attack it. But let's go ahead and get into the demo on this one. Okay, we're back at our terminal windows here. So the first thing that I'm going to do is This is on my local box in the SSH demo directory. I'm going to go ahead and create that key, and you do that with SSH. Well, before we do that, let me just show you the version that I'm running. I am on a Mac. The default, I'm not using the default Mac install. I did do a brew install and used a different port of OpenSSL and OpenSSH onto this machine. So just be aware of that. But everything should look exactly the same if you're using the default. SSH keygen, we're going to use TRSA. This is the type of key that we're going to create. And I'm going to put a comment on it. And I like using the comments. You don't see that in all the examples. It'll default to the host name. I like to put the comment because I have a lot of different keys that I create just for demos. And this allows me to know which one is which. So in this case, I'm going to call it demo2. And then the file that it's going to dump out to is going to be locally here. And I'm going to call that also demo2 with no file extension. Just leave it as demo2. It's going to ask me for a passphrase. I'm going to password protect that. And it went ahead and created that file. Now, let me do a real quick ls, and you see that I have two files here, one called demo2, that is the private key, and the one with the .pub at the end is your public key. So let me go ahead and copy the demo2 public key over to that remote machine. So ssh2.lab.loc, home, our booth, and into the SSH directory. It's going to ask me for the password for the remote machine. And it's copied that file over. So now on that remote machine, I'm going to log in. And now that I'm in on this machine, let me go to the SSH directory, and I can see that I have that demo2.pub file, and I have this file in there called authorized keys. Now you may or may not have this authorized key file there, that file there already. You can just simply create it if you need to. Let's look at what's in there right now, and there's nothing in that file. So what I'm going to do is I'm going to add, and I use the two greater than symbols here to append. I like to use this more of a safety thing so I don't overwrite something that's in that file. So demo.2.pub to authorized keys. Now if I look at the authorized keys, I can see that my file is in there. And you can see at the very end of that public key, it does say demo2, which was the comment that we used to add to that file. It starts off with SSH-RSA, which is telling us the type of key that it is. So let me log out. And I'm in the same directory up here that I am down here. Hopefully that doesn't confuse you. So I'm going to SSH, but this time I'm going to provide -I, which is for my identity that I want to use to log into that machine. And I'm going to use demo2, the name of the private key file that I have. And I'm going to go rbooth at ssh2.lab.loc. And this command, it should not ask me for the password, but it will ask me for the passphrase, and the passphrase is for that private key. So I'm going to hit enter, and you can see that it says enter passphrase for key demo2. So I'm going to type in the password, and now I'm authenticated out to the machine. So that's a very easy way of setting up a public-private key pair SSHing into the machine. Now, if this doesn't work for you off the bat because the machine's a little older or whatnot, there may be some SSHD config file changes that you need to make. But by default, most machines will provide exactly what I have here. The Ubuntu box that I'm running this with has, all I did was update the patches on it prior to the video here. So with that, let's move on to the next section. Okay, this next part, one of the challenges with the first one was that it was just a username and password. And the second one, the challenge there was, now I have a larger administrative overhead because I need to copy my public key out to all of these remote boxes that I need access to. So that's why I said that we should only do the public-private key pair for a small group of machines, which is fine. But if you want to step up for like an organizational deployment, you can use a certificate authority to do that. Here, what we're doing is we have, during my demo, I'm using my own certificate authority here, which is just a public and private key pair. I'll walk through all the steps that are needed for it. But the idea here is that you still create your public and private key pair, which I indicate here with the private key being the green in the circle, with my public certificate, which is the green certificate that we saw on the previous screen. But this time, that green certificate, we're going to have it signed by our CA, and then that CA is going to provide us a certificate to use for authentication. After we have this, then we can SSH in with our account. We don't need to copy our public key out to the remote machine. The public key for the certificate authority should be copied out to all the remote machines, and that's the only certificate that needs to be deployed. So you only have one certificate on those remote machines, and that's the certificate authority. What does this do for you? It lowers your administrative costs, so there's no need to push out user public key files. The other thing is you can now look at deploying out a certificate revocation list, which will allow you to revoke different certificates that you may have signed in your organization. So there's an easy way, one central file to be able to do that in. Now, some of the deployment challenges, you need to make sure you control your certificate authority. You have to have some very strong technical controls to make sure, administrative and technical controls around that CA. On top of the controls there, one of the things that is a challenge with this deployment is restricting some of the attributes that get put onto the certificate. The way that I'm going to show you here, it's a very free way of doing it. I have no controls in place to be able to prevent, let's say, additional accounts being added to the certificate that gets created, so then I can log in as another user, let's say, into the machine. So you want to make sure that you have a lot of controls around that creation there. Now, an adversary can still exploit this. This isn't adding any additional security. From the previous example, all this is really focused on is lowering your administrative costs and being able to have a little bit more defined organization control. So with that, let's get into a demo. Okay, we're back on our demo terminal here, and the first thing I'm going to do is, and this is going to be local, I'm going to create that certificate authority. Now, of course, this isn't the way that you'd want to do it in your production environment. I'm just demonstrating this. You're going to want to make sure this is on a very secure machine, because this is the key to your organization security here. So we're going to do SSH Keygen. We're just going to make a RSA type key like we did before, and we're going to add a comment into it. And I'm going to call it SSH demo CA, and the out file is going to be demo CA. So you can see that command looks almost identical to what we had for the other machine. So let's go ahead, and it's going to ask me for a passphrase, just like it did before. You're going to want to make sure you put a passphrase on this, and it's a very strong one for the organization. So it went and created it. Now the next thing I'm going to do is I'm going to copy that public key. Well, first let's see. It created the demo CA file, which is the private key for the CA, and the .pub for the public key. So let's go ahead and copy it over. And we're going to use our identity that we already set up on that remote machine. And we're going to do the public key, ssh2.lab.loc, because we need the CA file out on the remote machines, and I'm going to jump out there and show you exactly where it goes. First, I'm just going to copy it over to my home directory over there. And it's asking me for my passphrase, and that's going to be for my private key. And it's copied it over. So now, if I go to log into that box, I can see that the demo CA certificate is out there. And if I cat that out, take a look at it, I can see that that comment is there, and it is an RSA type key. So we're good. Next, we are going to need to go to, I'm just going to sudo to the root account. You should run the commands as sudo, but I'm going to run it just as sudo su. And the first thing that I need to do is I need to put that file in a location on the machine that the SSHD service uses. And we're going to call it CA Keys. So etc SSH user underscore CAN underscore keys. I'm going to cat that out to it. And then I need to reconfigure my SSHD service to be able to use that file. And the way that I do that, I need to go to the config file for SSHD, and I'm going to add an additional line. This is all defaults that I currently have in this file. And the line that I need to add is trusted user CA keys, and I am going to look at that file that I just created. So now that that's created, now what I need to do is I need to restart the SSHD service so it reads in this new config that I just provided. And we'll go ahead and restart. And I'm going to exit as root, and I'm gonna, so these keys were here that we put in for the authorized key file and the public key that I have. I'm going to remove everything here. And that should prevent me from logging in with those certificates. So let's go ahead and exit out. And now, let me try to SSH in with the demo2 account at ssh2.lab.loc, and this should ask me for a password, and it does. And the reason it does is it doesn't have my public key in the authorized keys file, so it defaults back down the password. Now, you would want to go into your SSHD config file and remove the ability for passwords to be used for logins after you get your system secure. But I'm not going to get into it because there's a lot of other hardening that you'd want to do, and I don't want to make this a video where it covers completely the SSH security. But I'm going to ignore all of that, and what we're going to do is, let's jump back down to this box. And I'm going to do an SSH key gen. Now, what we're going to do is we're going to sign our demo to public key. So let's go ahead and keygen, and we do that by using the -s, and we're going to provide the demo CA private certificate, so it's not the .pub. The .pub is out on the remote machine, and this is the private key used to sign. So whenever you do this operation, it also needs to be on a secure machine. And we're going to use -i, and we're going to call this rbooth. This -i allows you to identify this certificate in a certificate revocation list if you decide to use that. We're going to use -n for the accounts that I want to use to log into the machine. We're just going to use my user account here, .rbooth. Again, this is where control measures should be in place, because whatever account I put in here, I'm going to be able to log in with. And then I'm going to use that demo 2.pub file, because I'm signing the public key, not the private key. And it's asking me for the passphrase for the certificate authority here. I typed that in, and it went ahead and created it. Now I see that I have a new file called demo2-cert.pub. So let's take a look at what that looks like. And it's a lot larger of a file. And you'll notice that it says SSH-RSA-cert. So this is different than the other certificate that we have. And one of the reasons for that is if I want to take a look at this file a little bit different, we'll do demo2 cert. We can use this command here, -lf, to decipher that file and be able to see what it's sending over. And you can see here the key ID is going to be rbooth. The principals, which is a list of the logins that I'm authorized for, will be here, and some of the other options here. Some of the extensions by default that get set on this. So there's a lot of critical information here. This is a much deeper subject, but this is just all defaults at this point. So now that we have that, let's see if I can log in now with that. Well, let's just go back like this. So the certificate authority is out on SSH2. I have a signed public certificate now locally, so let's see what happens. It's going to ask me for my passphrase for my private key. I think I typed it in wrong. Oh, I typed it in right. And I'm logged in. So it asked me for my passphrase for my private key, and it authenticated me in. If I go into the .ssh directory, there's nothing in there. There's no authorized key file. So it was using that certificate authority to log me into the machine. All right, so that completes that demo. Let's jump back to the next section, which is getting into some good stuff. Okay, in this section, we're going to get into using FIDO keys for your SSH keys. This is a huge improvement on security for SSH, and it's fairly new, and there are going to be some requirements that you're going to have in place to make this happen. But the first requirement is you're going to have a security key, and there's a lot of different security keys on the market. The one that I personally would recommend, and I'm biased towards, is the YubiKey. So you're going to see the picture here of a YubiKey to be able to authenticate in. But what this is doing is it's almost exactly the same as the previous examples where you had a public and private key pair. Except in this case, the private key is going to be stored on the YubiKey. It's going to be created there. It's never off of the YubiKey. So it's very, very secure. And we'll walk through that example and show you how it works. But again, it's going to create a public key. We're going we're going to take a step back from the certificate authority here for our first example. And you're going to have to take your public key and you're going to have to transfer it out to the machines that you log into. This is just like the previous example that I showed on this. The really nice part of just a simple deployment with the YubiKey or a security key deployment is that even if an adversary gets a hold of your public key or any of the files on your local system, there's no way that they're going to be able to authenticate out to that remote machine. They don't have the secret key. They physically have to have your YubiKey to authenticate in with. So this is a huge security benefit for your organization. The other thing that it provides you is a very secure portable private key. So you can, if you're an admin, you need to go to different machines. This is a good way of being portable with your private key. If you have to log on another box, there's going to be no remnants of your private key on that box. So this is a huge increase in security. You still, though, have the administrative overhead of copying out the public keys out to the remote machines, and I'll show you how that looks as well. And the biggest challenge that most organizations, large organizations, are going to have with this today is that it does require Open SSH version 8.2 or newer on the local and the remote machine. So this might be a blocker, but I would encourage you to move as fast as you can to 8.2. I've been in large organizations where it's just boxes you just don't touch, but I think that's changing more and more nowadays because of the security compromises that have been out there. So best practice would be is to have the latest or near the latest OpenSSH version deployed. But for this, you're going to have a requirement of 8.2 on your local and your remote machines. One of the only risks that I see here, there may be another one, but the one that I see is if an adversary gets a hold of your YubiKey. These attacks, they could happen. That is a very direct attack. It's very rare that, unless you're a very high valuable target, then you're going to want to provide some additional security to that key. But in this case here, for the majority of users, this is going to be a very, very high level of security. So with that said, let's get to a demo and show how to set it up. Okay, we're back at our two terminal windows. And I'm gonna exit out of the login from the remote machine, and I'm gonna clear both the windows. Now let's do a man SSH for keygen, and I want to point something out here. Whenever you run this SSH keygen help menu here, this here for the -T, you're going to want to take a look at it, but don't hold this as the version of software that you're running will support all of these. The two that support the YubiKey, of course, or the security keys, are going to be ECDSA-SK, and the other one here, ED25519-SK. What you'll find is on your default deployment for a Mac, it will list both of those, but when Apple compiled OpenSSH, they actually disabled that ability inside of their default deployment. That may have changed, but if you get an error and you haven't updated your SSH version from what deploys with Apple products, that's going to be the reason why. Even if this menu has them, it will not support it. And you can check online. There's a few articles that cover that problem there. It's just, that's very bad. I'm sure quite a few people bang their heads against the wall finding that out. All right, but let's get moving on to our system, because we are not restricted by that. And we're going to use our SSH keygen command again. And again, this time we're going to use -T, but we're going to do the ED25519-SK. And let's see here. We're also going to do a comment. I'm going to say my YK5CI security key. And we're going to dump this out to my demo. I'm calling this demo 4-SK. And it's going to ask me for the pin for my authenticator because I have a pin set up on my FIDO key. And then it's going to ask me to touch it, which is another additional security item that we'll have here. And then it's going to ask me the passphrase. I'm going to go ahead and put a passphrase on the private key as well as the pin that I had for my YubiKey. So I can still have the security of that, the password for the private key, even though you need to have the YubiKey for the private key to work in this scenario. All right, so now let me clear this window out, and we can see we have the two files created, demo 4-SK, which is the private key, part of the private key. The real private key is on the security key that you have, that you use, and then you also have the demo 4-sk.pub. And you're going to do the same thing that you did with your other public and private key pair. So what we're going to do is SCP, we're going to use demo 2 as our identity, and we're going to use that demo 4 sk.pub. And home, our booth. We're going to put that in a .ssh directory. Now I'm using the demo 2 public and private key pair here, and it's copied it over. Now I'm going to log into the remote machine with my passphrase, and I'm going to go into the SSH directory. And I can see that I have that demo 4-sk public. What I'm going to do is what we did on the other system, or when we did the without the CA, authorized keys, we're going to dump it into that. So now if I look at authorized keys, I can see that my public key, which is much shorter than the RSA key, gets dumped into it. And you can see that this is a security key, public key, because the beginning of this starts off with sk-ssh, and it tells you the algorithm that it used there. So we should be good there. Let me check. All right. Let me exit out. And now I'm gonna log in with my demo 4 identity. Okay, so this is using my demo 4, which is my security key, to be able to authenticate out to that box. ssh2.lab.log. It's going to ask me for the passphrase, and it's going to confirm, it's going to ask me to touch the key. So it's blinking, I'm going to touch it. Did I touch it? May not have touched it. Yep. Took a little bit to authenticate in there. And you got to see a UBOTP code when you when you touch it without the FIDO authentication. Just disregard that. You can remove that. All right, so that was fantastic. That used a security key to authenticate into the SSH box. So we're good there. So let's move on to the next level for the FIDO authentication. Okay, so just like we did with the other public and private key pair, and we used the certificate authority, and then we started doing this with the YubiKey. Well, if we just use the YubiKey like we just showed, then we'd have that administrative overhead of copying out the public key to all the remote machines. But in this case, we already have that CA certificate out on the machine, so we're going to use that same certificate authority to be able to sign the public key from the security key. It's pretty straightforward. It's exactly what we had before, but we're going to get the benefit of having a certificate authority and lower administration costs. So it's the same thing, and we can also use this with CRL, so you can increase your security there to revoke keys. And it's the same benefits that you get with the certificate authority on the public and private key pair, but you get an additional factor that you have a user presence that you need to touch on the key. So with that said, let's get into the demo. Okay, so to kick off this last demo that we're going to cover, what we're going to do is we're going to jump into the SSH directory, and we're going to do the same thing that we did for the previous example when we went to the certificate authority. We're going to remove everything from the SSH directory. So let's go ahead and do that, and let me exit. Let me again try to log in with the security key, which was just working, and it's going to ask me for the password. Again, you can lock this out so it doesn't ask you for a password, but we're not going to show that in this video here. All right, next on the local box, we will use our SSH keygen to sign just like we did before. So we're going to use that demo CA, R booth. I'm going to use SK as my identifier. Use my username here, and then demo4.sk. Remember, you're signing the public certificate, not the private one. So I use a .pub, and it's going to ask me for the passphrase, and that's the passphrase for the certificate authority. And it has signed the key. So I should have one additional file here, and I do. It's called the demo4skcert.pub. So with that, I don't need to copy anything over to the remote box. All of the remnants of the previous security key keys are gone from that remote box, but the certificate authority is still out there. So if I do -A and I do my identity is going to be demo4 security key, I'm going to log in with R booth. It's going to ask me for the passphrase for the security key, and it's going to ask me to touch my key. So let me touch, and I'm logged in. That's using a security key to authenticate out to a remote box via SSH, using a certificate authority as the single certificate that's out there. So the demos that I covered today, I have the documentation for this. I should have a link below. And let me know how it works for you if you have any questions. There are some additional videos that I have coming out. There was some things that I pointed out about the signing process that I didn't cover in this video. One of those aspects was being able to have technical controls around signing these SSH keys. And there is another product from Yubico that's called the UBHSM that provides SSH templates that provide you the ability to do that, at the same time securing your certificate authority inside of an HSM. And I'm going to have some videos that kind of walk through how to do that as well. So those are coming up, but I think this is a good start to get an overview of moving away from using files for SSH login to using a security key. It's a very easy transition as long as the versions of OpenSSH on your local and remote machines can support it. Again, please drop a message down below if you have any comments on this. I would appreciate some feedback on it. Thank you very much, and thank you for watching. Bye.